All right, cool. Hey, everybody. Thanks for being here. Today, we're going to talk about bringing a superior developer experience to Web3 and how we're doing that at Fuel Labs. And we're going to cover a lot in the next 30 minutes. So, we're going to go over kind of an overview of Sway, the programming language, the VM, and kind of what makes Fuel such a good option for building dApps. And then we're going to talk about specifically like going through a workshop. So, if you have your laptops, you'll be able to go through it either in real time or you can go through it during the hackathon. So real quick, just a quick about me. Like I said, my name is Camila. I had a kind of a more traditional path to engineering. I studied computer science in college. Then I started my career at PayPal, where I was an engineer before moving on to developer relations almost 2 years after that. I did developer web 2 for maybe like a year before pivoting over to crypto. I've been working in crypto full time since April of this year. And now I'm the head of developer relations at Fuel Labs. So before we start, let's just kind of get like a ground zero where we're all under the same understanding. So when we talk about a tech stack, I find it easiest sometimes to try to map the Web 2 tech stack to the Web 3 tech stack and kind of draw those relationships so we're both clear on what it is that we're talking about when I say certain things. So when you're building in Web 2, these kind of 5 pieces basically are the primitives that let you build pretty much anything, right? You have APIs, authentication, database, client-side frameworks, and file storage. So now if you take that similar idea and kind of try to map it over to Web3, it's not a one-to-one, right? Because there's a different paradigm to building, but you can kind of map a similar map of all of the different pieces. So this is back from when I was at Edge and Node. The team there did research. This was a year ago, actually, almost exactly, where we published this research. And as you know, like stuff in Web3 moves super fast. So a year ago, things were way less mature and way more nascent than they are now. So there was a much bigger need to define what a working tech stack could look like at the time. And this is what they came up with. So you see, you have your layer ones, you have your layer twos, you have your development environments, file storage, indexing and querying, oracles, identity, wallet, and client. Okay, so Fuel Labs, that's the organization that I work at. We're building Fuel, and I kind of like to nickname it a layer two, but better. But the official term that we use is a modular execution layer. So what that means is that, you know, instead of it being just a layer two in maybe the sense of like it being a roll up or a sidechain or whatever kind of different types of layer twos there are, it's a execution layer that can be plugged in. It's the engine that can be plugged into any different L1 or to any different configuration where you can have Fuel as a sidechain, you can have Fuel as a roll up, you can have Fuel. We don't recommend it, but you could have Fuel running as a monolithic L1. You could have all of these different configurations, and that's kind of the whole modular idea is that you as a protocol developer can define what you want your chain to look like, and you can say, I want to use Fuel for execution, or I want to use Fuel for execution, but I want to use it as like a sidechain or something like that. And the 3 pillars that we're going to talk about our performance. Wait, it's so small on my screen. There we go. Performance, flexibility, and waste reduction, and developer experience. And the 2 that we're going to focus on today are performance and developer experience, just because we don't have a bunch of time. So for those who might be like, oh, what's a modular execution layer? What does that mean exactly? So really what it means is that blockchains have these 4 functions, and we have a bunch of reading on our website if you want to kind of learn more about this. But basically, blockchains have 4 functions, and when you have a monolithic chain, the node is stressed trying to do all 4 things, right? So you have this like limited set of computation power, and then you have to divide that by all these different functions. And the thesis of modular is that if we can separate these out, we can have higher performance on each layer individually. So when you combine them, you have higher performance in general. So what Fuel does is it offloads just execution. So the chain only handles execution. It doesn't worry about if something is correct. It doesn't worry about settlement. It doesn't worry about consensus. It just executes all of these state changes. So it'll execute all your transactions and then post them back to the L1. And then the L1 is in charge of saying, what order are we going to put these in, blah, blah, blah. So again, the Fuel VM is designed to be modular and it can plug in as an execution engine for any blockchain. It's kind of like the thing to note. All right, so when we talk about Fuel building the fastest modular execution layer, how exactly are we doing that? What are we building that makes it such? So the 3 things that we're going to focus on are parallel transaction execution, the Sway language, and the Fuel VM. So I made this meme, laugh, because right, the vibe is how do we stay in the Ethereum ecosystem, right? Because we all, for one reason or another, are like either value aligned, technology aligned, whatever aligned with Ethereum. But how do we take what we know and love about Ethereum and improve it? So the thesis of Fuel is like, how can we bring a more safe smart contract language? How can we bring a more performant VM while staying in the Ethereum ecosystem? So let's talk about what we mean by parallel transaction execution and how that what that actually means. So the EVM, which is the virtual machine for Ethereum, versus the Fuel VM, which is the Fuel's virtual machine. So the EVM is single threaded, and because of that, it can only process transactions sequentially. So what that means is it can only process one transaction at a time. Once that one is finished, then it starts on the next one, etc. So because Fuel is UTXO based, which we don't have to get into the weeds of what that means, but basically it's a different model. Ethereum uses an account model. The Fuel VM uses a UTXO model. Again, we have a lot of reading on our page where you can kind of dive into this more. But it uses all of your machine's cores and threads. And because we're a UTXO model, we have access to these things called state access lists, where what that means is it looks at the transactions and it says which ones have dependencies. Like first you have to execute this one and then this one, let's say, right? Out of 10 transactions, there's like these 3 dependencies, let's say. So what the VM is able to say is, okay, let's execute all of the other ones that don't have any dependencies in parallel, and then the ones that do have dependencies, sequentially. So just based off that, you're able to get much higher throughput just off this one improvement, right? Where instead of having to do everything one at a time, you now are able to process things in parallel. So if we look at this graph, if you see the orange like triangles at the top, you'll see that the number of transistors on CPUs has been increasing exponentially over the years, also known as Moore's law. The single-threaded performance over the last years, which is the blue right under that, hasn't. You can see like it was increasing, but it's not increasing exponentially. But what has increased exponentially over the years has been the number of cores. So if you have a system that's sequential that can only leverage a single core, it's like you're running it on a 10-year-old laptop. You want to leverage the things that are increasing exponentially year over year, and the Fuel VM is designed to do that. It's designed to be able to run transactions in parallel, and this leads, like I said, to a vast increase in throughput if all other things are equal. So not considering any of the other improvements, just because of this, you're able to actually access all of the cores and all of the threads of your machine, which, like I said, according to this graph, is what's been growing, is what's been improving. So, and it's not because you bought a better computer, right, or a more performant like machine. It's just because you're using all of the resources that in your computer are wasted in the EVM. The other thing when we talk about developer experience is that the Fuel VM uses a GraphQL endpoint instead of a JSON RPC. If you've like deployed a contract, you got to go find like the RPC endpoint and you just like paste that in and that's how you deploy. So with Fuel, we have a GraphQL endpoint, and what that means is that you have a GraphQL API built in. So you might have heard of the graph, right? The graph exists because these other networks don't have that. So you need an external service or someone else to build this layer on top of it. And with the Fuel VM, so this you guys can't see this. Oh, you can see it here. With the Fuel VM, this link right here is actually the endpoint to where you deploy your contracts. So if you were to click on this, did it open? Okay. So if you click on this endpoint, it'll take you to a GraphQL playground where you can actually start making requests right away, and you don't need an external service. You don't have to write new mappings. You don't have to like write the whole API that you have to do to use the graph. You know? Okay, so now moving on. Sorry about that. So now moving on to the portion of developer experience, and we're going to talk about Sway and Fork. Sway is the REST-based language, and Fork is the tool chain kind of manager. So we're going to just kind of like fire through because we only now have a few minutes left. We have 20 minutes left, actually, so it's fine. So we're going to kind of speed through some major points. We're not going to get into too much detail, but all of these have QR codes, so you can, scan them and go into the actual specs or into the docs and read more about what I'm saying. So our standard library is actually written in Sway, and the reason why that's notable is because a lot of other languages for blockchains are actually not written in that language. So for example, like Move, the standard library for Move isn't written in Move. So that's like something that's really interesting about our project is that the standard library is actually written in Sway. So the standard library can move fast, and this is because you don't have to wait for the compiler devs to add features. So for example, if you're like, oh, I have an idea for a library, I want a library, I don't know, for like super scientific addition with like 27 decimals, let's say, you can just write that library and then it'll just work. So you don't have to wait for the official compiler team to like build that in and add support for it. You can just write that library yourself. So because the language is lean, it's able to move much more quickly. Is it back up? As just as a side note, we have a grants program, and here at the hackathon, we have a booth over at the like kind of in that little corner before you go into the main stage. So if there's something that you build here and you're like, oh, we kind of want to extend this, or we just had a great experience and we want to build something else, the grants program just opened up maybe a month ago. So it's like super open for projects. There's about I want to say like 15 to 20 projects building right now on Fuel through the grants program, which is really fun. And because it's such an early developer ecosystem, well, at least for me, what I think is cool. Did it work? is like you can have like a pretty heavy hand in like influencing and building the developer ecosystem because it's so early. So imagine being like one of the first 30 projects on Ethereum. That's kind of the vibe right now where it's like we're still super early in standing up the ecosystem. So if you have an idea, you can be like the first X. So right now we have the first team building an Oracle on Fuel, which like, by a later stage project, like they've already done that. So any idea that you have, it's very likely that you're kind of the first person that's building this out in the Fuel ecosystem. So just a note, and we support through grants, and we're building out this accelerator program to connect teams with VC funding if that's something that they want to pursue, to connect them with like legal and marketing if they want to like pursue kind of turning this into a real company, or if you're just like I just want to build some cool shit and get a grant to support it, that's also like a option that we have. Okay, so the other thing about having a standard library, so like Solidity, for example, doesn't have a standard library. So if you've ever tried to like do an ERC20 or ERC 721, what people typically do is they go look at like a bunch of big like Uniswap or the big kind of orgs and see how they've done it, and then they try to deduce and kind of like piece together what the best way to do it is. So with Sway, you have this like single source of truth for certain things instead of having to compare the code that like 7 different orgs wrote to have like a custom ERC 720 implementation or something like that. The other thing that we have that's really cool and kind of the overarching uh, thesis or idea around this is like everyone who's written in Rust loves Rust. Like you've never met someone who writes in Rust and they're like, I'm going back to like whatever. Everyone's like fucking Rust, like I love it. And there's a reason why, right? You have this like built-in type safety, you have this compiler time stuff where it, like yells at you at compile time. It won't even let you deploy something that has these issues. So you kind of harness that in an adversarial environment like blockchain, where you're dealing with real money, you're dealing with real assets. You want to be in a language and in an environment where something is saying, hey, on line 36, like you have XYZ, we're not even going to let you build this contract, much less deploy it until you address it. So these are the next few things I'm going to talk about is kind of how we do that. So the first thing are these things called generics and sum types. So generics, if you've ever written like in C++ or something like that, you know that you can kind of like define a function, but not define the type right away. You can just say like for any type, and then later on you can actually use like int or like string or whatever it is. So let's just say, for example, addition. You can write a function called add and then use a generic type because you're saying, I might want to reuse this logic for both ints and floats. So instead of rewriting the function twice, you can just use this generic type so that you can basically reuse logic without having to rewrite code. And then the second portion of this is sum types, which is kind of like unions where it's like one or the other. So let's say you have this enum called result, right? And you could have in a result, you could either have like a successful or a not successful. That would be a sum type. So when you put those two things together, it allows you to. I wish you could see. Okay. So if you can imagine these two things together, where like you can define the types later, and you have these sum types where it's one or the other, what happens is that you don't have to in Solidity, you would have to rewrite this for every single type you wanted to use it on. That's the first thing. And then if you wanted to have similar logic where you're like one or the other, you wouldn't be able to do it in the same way. And I have an example up here, so maybe when it's working, we can come back to it and you guys can see. Okay, the other thing is explicit error handling. So if you guys know in Solidity the EC recover function, do you guys know that one? Okay, do you guys know what it will return if a signature is invalid? It returns a 0. Just returns 0. It returns 0 address. So what you have to do as a developer when this happens is that you have to go in and you have to check for the 0. Like you have to remember, you have to say like if 0, like whatever, do this to handle the error. And what does that mean, right? Like you could forget, you could not know, or you could just like straight up, I don't know, just not handle that case, just not even out of not remembering, you could just not do it. So what that means is that you might have this like variant path where you're not actually handling an error case that could be very problematic. And in Sway, we have explicit error handling. So you can't see it again, but like with the results that I was talking about in the last slide, where we're talking about successful or like non-successful, you can actually wrap the return of things. So instead of if you just try to like run this code and it returns nothing and you don't handle the error, Sway will tell you that you're not handling the error first at compile time. It won't let you build your contract. It'll say you haven't done it. And then 2, it forces you to call this method .unwrap on it to actually see what the error is, to actually like access, to access one level in. So in Solidity, you have to manually remember. In Sway, it's done at the language level, at the compiler level. It won't let you build, it won't let you deploy unless you actually handle all the errors explicitly. So again, like what does this lead to? Safer code, better applications for end users. The other one is type inference. Oh, did it work? It glitched over here. No? Okay. Type inference with the same type system as Rust. So basically, it can infer the type. So even though you're writing in Rust, which is like a language where you're thinking of types all the time, you can just say let, for example, let answer equals 42, and the type will be inferred. So you don't have to say like, let like int or float or whatever. It'll just infer what's on the other side of the equal sign. The thing that I think is really cool is this concept of namespace storage access. So, for example, in Solidity, you might have like a storage variable, let's say called count, and then you might have a local variable called like CNT or count underscore or something like that, like a nomenclature where it's similar because they are related in some way in your code, and that's why you name them like that. But they do different things. One accesses storage and one doesn't. In Sway, not only do you have to define the type of storage access that a function has, in the actual function definition itself. So you say read or write or both or just write or just read. And so that's the first thing. You have to define when you define the function. And then two, when you're actually wanting to access storage, the way that it's done is storage dot and then the name of the variable. And so what does that mean? Two things is one, when you're writing, for you as a developer who's writing and any developer that's perhaps using a library that you wrote, it's explicitly clear what type of access to storage these functions have. But number two is you'll never kind of have this error of like you accidentally access storage or you access storage in a way that has unintended effects because you didn't necessarily know you were accessing storage. You were just like trying to reference a variable that you might not have known was actually in storage. So with Sway, it's super explicit where if you want to access storage, you have to use the storage keyword. And if, for example, you didn't define that type of access on that function, it won't even let the developer do that. It'll just, at compile time, it'll just not work. It worked? Okay, great. Yay! You guys can see this big now? Okay. So this is what I was talking about for generics and sum types. So if you see this result, when I'm talking about explicit error handling, so this is the result I'm talking about. When I'm talking about explicit error handling, you can do this unwrap method on result to actually access what was it. Was it okay or was it error? So that's what I was referencing earlier, and then this is the explicit error handling. That's kind of what I mean when I say it forces you to call this method unwrap to actually see the error. Okay, we're going to speed through this. Oh, so this is what I meant when I say access. So here, you're actually saying this function increment has both read and write access, while this storage only has read access to storage. Okay, exhaustive pattern matching. So a match statement to exhaustively enumerate all possible cases, and the compiler will tell you if you miss a case. So basically, instead of having to like again manually remember to do a bunch of if else's, like if it's true, if it's no, not true, if it's 7, if it's 10, if it's 24, if it's like 100, you have to manually remember to like write all of these if else branches. But with Sway, you have exhaustive pattern matching, which is this match statement, which you can look in our docs. But basically, it'll tell you that if you miss a possible path. So again, how do you write more safe applications? How do you make it safer for your users to be using it and not be kind of at the will or the whim of like a developer making sure that they cross all their T's and dotted all their I's? You use something like Sway. Okay, reentrancy. This is the most exciting feature that we have coming up. So you guys all know what reentrancy is? Okay, so I won't use this. So here's this list that I found, or actually John found, which is like this list that's maintained of all the reentrancy attacks to date. And you can see the last one was September 30th. And that's only because I screenshotted this around that time. There might have been another one since then. But with Sway, at the compiler level, it'll call out if you have a potential reentrancy vulnerability. So it'll say on line 36, you have a potential reentrancy vulnerability. Please address it. So we all know what it means, but I'll kind of just go over it for maybe people who don't know. You might have the case where it's like you have a function where, let's say on line 27, you're sending some money, and then on line 28, you're flipping some Boolean to let the program know that the money has been sent, right? So that's how you could be, one way that you could be vulnerable to reentrancy is because someone could just keep calling some function that keeps getting to that first line of the execution of that function where it just keeps sending the money over and over, but never actually makes it to that line where it flips the Boolean to true or false or something like that. So that's something that the compiler will call out. And again, it won't let you build your contract. It won't let you deploy your contract until you address this. So with Sway, this list should be 0. This reentrancy attack will never happen in Sway, period. Okay, Fork is the fuel orchestrator. It's the equivalent of Foundry, Cargo, NPM. So it's what does all the builds, manage dependencies, deploy, format, test, the language server. So I kind of made this map to kind of show like part of the draw of Fuel is not only all the things we just talked about, but it kind of unifies part of the developer ecosystem and the developer tooling so that instead of having to rely on this like kind of fragmented ecosystem, right? Where one team built Foundry, one team built Hat, one team built the EVM, one team built Solidity, one team, there's like all of these different things that you kind of have to make them work together as a developer. You have to work with like versioning. You have to make sure that everything's talking to each other, that works well. With Fuel, we're like, let's just build everything in-house and make sure that everything's always maintained up to date. So for developers, and that's what I'm going to show you here, you don't have to worry about installing Ethers, installing WAGMI, installing Foundry, using Hard Hat, copying and pasting your ABI, like all these different pieces to make it work. Okay, now let's just speed run writing a Dapp on Fuel. Can you guys see my desktop right here? Okay, cool. So this is following the developer quick start, which I'll pull up here just so you can see. You go to fuel.network, you hit read the docs, developer quick start. So we're gonna follow this. So if you don't, if we don't get through it or whatever, this is how you can do it. So we're literally gonna speed run this baby. So you just have to install the REST toolchain, install the Fuel toolchain, and then I'm just gonna go ahead. I already installed that, obviously, so I'm just gonna start. So I use Warp as a terminal, by the way. If you don't use it, you should check it out. It's cool. Warp. Yeah, it's really cool for a lot of different reasons. So what I'm going to do is I'm going to make a new thingy-mabob, a new thingy. Then I'm going to make a new project. So the way you do it is fork new. And then I'm going to call it something. I'm going to call this one counter. Oh, I didn't CD into it. Sorry. How about now? Can you see my VS Code, though? Okay. I'm gonna zoom in. Okay, cool. So now we did fork new and then the name of the thing, I just called it counter. So if you open this, we have a main file. This is where we're gonna be adding all of our code. So in this thing, we're just gonna define a simple contract where there's a counter function to increment and then a counter function to grab the current value. So I'm gonna go here and just copy this. And then we can talk about it. Where are you? Okay, so the first thing that we're gonna do is define our ABI. Now, if you were building a real like quote unquote kind of real project, the way you would do this is you would define your ABI in a separate file because the idea is then another developer could use this library and say like, if I built a library for, like I said, like scientific math or something, I could just define this ABI and then you could use my ABI and define your functions. But we're just gonna do it all in one because time. But let me just copy this whole thing actually. And then we'll talk about it. Delete. Oh, why didn't it copy? Okay, there. Cool. So the first thing that we're doing is every Sway contract starts with defining what type of file this is because you can have a contract, you can have a library, which is what I was talking about, where you would just define your ABI in another file. That would be a library. You can have a script. So we're defining a contract. So you'll see what's cool. I really like this. I'm a visual person. Is the storage variables are kind of grouped together in this object-like syntax if you're coming like from JavaScript, which is really nice because then you could have like another one, and they're all together visually. So you can just scroll to the top and be like, what are my storage variables? Then we defined our ABI, which are just two functions, increment and count. So here you see there's actually no function body. That's what you would implement in your actual contract. But like I said, we're doing it all in the same file just for simplicity's sake. So here's where we're implementing counter. So we implement this one that's just count, which just returns the value of counter, which starts at 0. This is the equivalent of this, by the way. So this is shorthand. You don't need the word return, and then you don't need the semicolon. And then here, increment does the same thing. It accesses the counter variable in storage, takes the current value, and adds 1. So we're going to go to terminal, fork build, make sure, fork build, make sure it builds, great. So now the next thing that we're going to do is we're going to build a front end for this. So there's actually a part here to write tests, but we're just not going to do that because we don't have time. Then we're going to deploy our contract. I already have test coin, so I'm just going to go ahead and do this. So here, if you guys can see, it says fork deploy --URL, and it's that GraphQL endpoint that I was talking to you about, because again, like I said, that's where you actually deploy, so it's not a JSON RPC endpoint. So this part that we're talking about, it's fine. It just was creating a new file. So this part that we're going to go through is like kind of janky right now because so Fuel and Sway in general is just very early. Like we just did testnet maybe a month ago. So there's still a bunch of parts that are in development. The wallet part is one of those things. So you kind of have to do this manually for now. But in the near future, you'll have like a browser extension wallet like everything else. So I'm going to do fork wallet list to show me all of my wallet addresses, which I only have one. So it says, please provide the address of the wallet you want to sign with. I'm going to pass it in. It's going to give me this transaction. I go back here, fork, wallet, sign, pass that in, and then index 0 because here, this address is index 0. Right here, the 0. That's where that 0 is coming from. And then do my password, and then it gives me back a signature. Then I give that back here. Okay, I know that was a lot, but it won't be like this forever. Then you copy your contract ID. I'm just going to put it, I'm going to put it here so I don't lose it. Don't look at my notes. Then, yeah, don't. Okay, cool. So now let's go back here. Now it's deployed to the testnet. We have our contract ID. So now let's go ahead and build a front end for it. So this kind of shows you how to look at it on the Block Explorer, which we're not going to do now. We're going to create a React project in the same folder. So we're going to cd out one. So we're in the big folder, and then we're going to paste this in, which creates a React project for us. And then after this loads, we're just going to install two things. One is Fuels. This is the umbrella package that includes all of the main tools, wallet, contract providers, more, and then the fuel chain, which generates your ABIs for you. So I'm going to go ahead and copy this while that loads. Okay, we're running like 1 minute over time, but I lost a few minutes, so it's fine. I feel like I can go over a few minutes, yeah. Okay, cool. So now we're going to go into the front end that was just created. We're going to install the two things that it wants, which are listed here. Cool. Okay, now the next thing that we're gonna do is we're gonna generate our types. And this gets done automatically with the packages that we just installed. So that's why we're installing them, because we want to be able to run this command that will automatically generate types. So if, let's say, you update your contract, like you're building your front end, you're like, oh, I want to add another function, or like whatever, I want to update my contract. You go make that contract, you redeploy it, and then by running this command, it'll regenerate your types automatically without you having to like verify your contract, copy the ABI, paste it in your front end. It'll just get done and imported automatically. So I'm going to copy this, but without this. Okay. And then here, I'm going to change the name because here I called it counter instead of counter contract. So there'll be a note in the quick start, but it's like the name of this, so counter. And then if we run this, you'll see successfully generated 4 typings. Done. Cool. So now what we're going to do is we're going to create, so this is another part of the thing that I'm saying is janky that you won't have to do. So we're going to create this file called createwallet.js, which basically makes it so that you create a wallet in your front end so that you can sign these transactions. I'm just going to copy this, paste it in, save, and then just run node createwallet.js. And then I'm going to copy this because I'm going to need this. Close your eyes. Okay, great. So now let's go to our front end project, source app.tsx, and we're just going to paste in the code from here. Actually, let's just... Nice. Okay. Can you guys see this? Should I make it bigger, smaller? It's fine. Okay. I'm just going to quick fix this. It just has the wrong... So this is counter contract. That's just the name of the project from the quick start. Here we just called it counter, so we're going to update that. Same thing here. Update that. Quick fix. Okay, cool. So let's talk through what this looks like really quick. So here at the top, we have our contract factory, and here what we're going to do is we're going to paste in our contract ID and our wallet secret. So our contract ID is this first one that we got when we deployed the contract. Our wallet secret is the private key from the wallet that we generated in the front end. So I'm going to paste that in here. Great. The other thing I'm going to do is I'm going to go get some tokens so this doesn't fail from the faucet. So I'm just going to type in faucet. I'm going to get some coins real quick. Great. See how fast that was, by the way? Just saying. Great. So now we have this. So this is just like a simple count thing where here we have a button. Here we have a button. Where are you, button? Here. Button where when we click it on the front end, it calls this function called increment, which is defined here. And this is how you actually interact with your contract. So await contract.functions.increment, and we know it's increment because it's defined as increment here. So if this were called like Apple, that's what it would be called there. Transaction parameters, we're passing the gas price to 1 because it can't be 0, and then we're doing .call. So that's how we like actually interact with the contract. So you see, you don't have to install WAGME or you don't have to install ethers.js. You don't have to install like external dependencies to be able to get your contract and your front end to talk to each other. It's all built in and unified in the tooling that's created by Fuel Labs. And then here, we want to, so remember, we have two functions, one that increments and one that just gets the current count. So we've called increment. Now we want to get the current count. So here, await contract.functions.count, which is this one, right? If the name was something else, it would be something else, but it's called count. So that's how we reference it, dot get. So now let's save this. Let's run this. Okay, and that was it. So you see, right? Like the thing that I kind of wanted to highlight is if you've ever developed apps for Ethereum, I was literally just, let me see if I can open it up. I was literally just trying to write something for the EVM the other day. And just like, I couldn't even get the compiler versioning to like work with the thing I was trying to write. And I got really annoyed and I just like gave up kind of. But like with Fuel, the thing that I really, really like about it is that you have this like way, way better developer experience and you don't have to deal with like puzzle fitting all the different pieces to work. Like we just did. So this slide, let me just show you like last 2 seconds. So this slide, we replaced this whole thing, right? Like we didn't need to use Hard Hat or Truffle or Foundry or Brownie or Anchor. We didn't need to use Web3.js or Ethers or Anchor. And then we didn't have to use the graph. Like we just removed three like key kind of pieces that you have to usually finagle with to get something to work, and it all just was integrated directly. Last thing I want to say is here are some resources if you want to check it out more. The first link or the first QR code is something called Awesome Fuel, which is basically this resource where you can find all the articles, podcasts, tweets, like all the best stuff about Fuel publicly. And then the second one is the Fuel book, which is the developer resource with the quick start, with information with the SDKs, and all the different stuff that you could want. And finally, thank you. My name is Cami. Emily right here is from the compiler team if you want to talk to her about compiler stuff and Sway stuff. And like I said, we have a booth at the front. And yes, thank you.